How can Callgrind profile C++ performance issues with Valgrind? Imagine being able to see exactly where your C++ program spends most of its time. That's what profiling tools like Callgrind help you do. They give you a clear picture of how your code runs at the instruction level. When your program slows down or uses too much CPU, you need a way to find the cause. Valgrind is a suite of debugging and profiling tools, and Callgrind is one of its most powerful for performance analysis. It records detailed data about function calls and how many machine instructions each function executes. To use Callgrind effectively, start by compiling your C++ code with debugging symbols. Use the -G flag to include source code info, and also add optimization flags like -02 or -03. This makes sure Callgrind can match the instructions back to your source code, giving you accurate results. Next, run your program under Valgrind with the Callgrind tool. You do this by typing valgrind --tool equals Callgrind followed by your program's name and any arguments. Callgrind will then execute your program and gather data on instruction, counts, and function calls. After the run, it creates an output file that contains all the profiling information. You can analyze this data to see which functions are taking up the most CPU time. It shows you how functions call each other, how many instructions they run, and the overall cost of each part of your code. This helps you identify the hot spots where optimization will have the biggest impact. To make sense of the raw data, you can use visualization tools like Callgrind or Callgrind. These tools load the Callgrind output and display call graphs and annotated source code. They make it easier to see which parts of your code are slow and why. If you want to focus on specific sections, Callgrind also allows you to start and stop profiling around particular functions using its C application programming interface. This way, you can narrow down your analysis to the most critical parts. Keep in mind that Callgrind measures how many instructions your program executes, not how long it takes in real time. So it's best suited for CPU-bound issues. It does not directly measure input-output delays or waiting times. Also, if your compiler inlines functions, their costs may be merged into callers, which can make it harder to see the true cost of individual functions. Using Callgrind in your C++ debugging toolkit can really help you understand where your program spends its resources. By pinpointing the functions that use the most CPU, you can target your improvements more precisely. This makes your code faster and more efficient without wasting time guessing where the bottlenecks are.